antenna, eaves multiple antenna. So there is a capacity. In communication, everything is quantifiable. So this is the communication channel H, the real channel. The legitimate communication channel is the illegal channel, or the eavesdropper channel. So some data transmission capacity in this link, some data transmission capacity in this. I already talked about power consumption in the cryptography. You need to manage the key session to session. So we need to look for information theory security. That's the physical layer security. That in physics, we have to create by any means a good channel between Alice and Bob, because Alice and Bobs are legitimate user. We have to create a bad channel between Alice and Eve, so that the capacity will be poor here, capacity will be good here. So difference between this capacity is large value, and that is our objective. So main idea is to exploit wireless channel to secure wireless transmission in presence of eavesdropper. Pointer says secrecy outage occur if the channel capacity of the main link below falls below that of the wireless. That means mathematically I define in the next that this is the define. So this is the capacity between Alice and Bob. This is the capacity between Alice and Eve. If this difference is positive, so it is secrecy. Now when this value is below a certain predefined rate, if this probability, that corresponds to the secrecy outage probability. That means this value is larger than this, or this value below this, that probability has to be small. So secrecy outage probability to be minimum. If this condition is satisfied, then communication is secure. I hope this mathematical point is clear. There is a capacity between Alice and Bob. That capacity can be improved. There is a capacity between Alice and Eve. The difference between this is the secrecy capacity. If secrecy capacity below a certain predefined threshold, which target, which customers or which users say, and if that probability is low value, that means the data communication is secure. Now, how a friendly jammer can be made? If you see a kind of a movie that's Basanto Bilap in Bengali movie, you can see that when song program was going on, some people, some other sides were shouting. So it's something like that. It's a kind of communication. Secondary transmit data to the receiver. There are multiple jammers. These jammers are friendly jammers. Their signals are a priori available to this one. That means they are jamming signal, as because they are friendly, this knowledge of these jamming signals are available a priori, before and to this. Now when communication starts, this is communicated, but this knowledge is a priori available. So it receives this signal plus this signal. Now cancel this signal, get back this one. But this eavesdropper does not have this signal as well as this signal. Neither have no signal, this signal and this one. So it is confused which one is the actual signal. So a friendly jammer is used to jam the eavesdropper, to create the interfering signal to the eavesdropper. And that way we can provide the secrecy. So jammer selection, out of the multiple jammer, one can think of the multiple or a best jammer who can create a best sound to the eavesdropper. So cooperative jammers can be used to confuse eavesdropper by transmitting this information, right? So with that, I will just, what we like to say, we have a promise of the physical layer security, information theory security. We have to create a good channel. So the capacity between Alice and Bob communication is high. We have to create a bad channel. So how it work? So as if we are at the mercy of the wireless channel, reconfigurable intelligence service. Here is the origin. This will provide that security. This will address the spectrum. This will address the energy efficiency. So reconfigurable intelligence surface will make use all these aspects of security, spectral efficiency, energy efficiency in the next stop. But here you can assume that you might have think that, oh, wireless God, channel, as if you are God. If you mercy, then Alice Bob communication will be good. If you have no mercy, then Alice Bob. But it's not like that. It can create a good channel or bad channel by means of signal processing, by means of coding theory. We are able to provide a secrecy to the legitimate user. We seems to be at mercy of nature. If Bob channel is stronger, perfect secrecy. If channel is stronger, no secrecy. Next slides like to say, we need channel advantage. Can we create a channel advantage? Yes. Wireless channel provides many topics, many options. Time frequency, multi-user diversity, multiple antenna. We can create a beam forming. cooperative and overhead signal, multiple antenna, reconfigurable intelligent surface provides this directional benefit. It can create a good signal in desired direction because a reconfigurable device will create the received signal multiple copies like a multiple vectors. If these multiple vectors reach it as a out of phase, so the signal will be weak. And if this multiple copies of the signal goes to the box in phase, the vectors are in phase, so the resultant will not. So that we'll be discussing in the next part. We have a lot of work, I mean, can be good number of works, all these over the last couple of years, at least 20 to 25 journal papers you have at least, but I just selectively select to only talk about just to complete this discussion. Here you can see a set of primary users, primary transmitter, a set of primary receivers. This is the central base station. So this is a set of secondary users. This is a secondary set of receiver. So this transmitter secondary transmit this one transmit to its secondary receiver. So every secondary transmitter transmit data to the respective secondary receiver. Now it has to, and there is an eavesdropper who eavesdrop the secondary communication. So what is our time frame? Our time frame has three parts. The first part, it goes on spectral sensing and energy harvesting. That means in a mode of power splitting. So what is done? That primary communication. What is that primary communication? It just sends all these primary communication. So this is the primary transmitter. This is the primary receiver. So all these secondary transmitter at the beginning of the time slot. In the next slides, this is there. So in the beginning of this time slot, sensing and harvesting simultaneously. So what it does, that whatever received signal is coming over here, so this is the primary signal, so all secondary are receiving that signals. Then a part of the received signal is used for sensing and a part of the received signal is used for energy harvesting. So rho and 1 minus rho. So the received signal into this is called power splitting mode. So in power, a part of the received signal power is used for spectra primary user sensing, and a part of this is used for harvesting. Now based on the disease, so all these are sensing, the sensing results, that is in the first time slot, in the reporting slot, the sensing signal is sent to the fusion center. The sensing signal is going to the fusion center for second, third one like that. So different time slots, over these different reporting time slots, all these secondary transmitters sends their sensing results, 1-0 result to the fusion center. And fusion center makes a global decision that whether primary is in transmit mode or in non-transmit. If it is in the non-transmit mode, then secondary will transmit data on time slot basis. So this is the PH0, means primary is not transmitting. It is make use by the secondary, so they are transmitting data on the time slot basis. This one is using this time slot, secondary this second is using this slot like that. So on the time slot manner, time division multiplex manner, different secondary, their respective communication is going on. If the hypothesis is PH1, that means primary is transmitting, then what these are doing? They are acting as relay and they are helping the primary communication to the relay. So this corresponds to the relay playing the role of primary cooperation. Now, what is our communication problem? The problem is the system model, as I say. So this was a paper which was published in IEEE Communication Letters. The system model shown in figure comprises of primary, secondary. I think so. It's a maximum k number of secondary and networks into the presence of eavesdropper. So the mathematical problem is what? The sum throughput of the secondary would be maximum. That means in different time slot, whatever respective secondary transmit data, that to be maximized, and there are conditions. The constraint optimization. The constraints are what? The sensing reliability. That means PD and PF value. PD should be greater than certain value. PF should be less than certain value. Then individual secondary outage probability. That individual data rate must be maintained. Individual secrecy outage should be maintained. Some secrecy capacity. That means all secondary user, it's not like that individual secondary communication is secure. It should be the sum of the all secondary user communication to be secured. Energy causality. That means individual secondary for its data transmission, whatever power is required, that power must be coming from the harvesting signal. So individual energy causality constants and some PU rate constant. That means for the cooperation. So secondary will do two things. One is the spectral sensing, its own data transmission, and cooperation. Three things. So during this sensing, it is harvesting, and that harvested energy must be larger to meet the cooperation of primary communication and its own data transmission. So some PU cooperation rate must be constant. So these are the different constants. This was the paper. I'm not going to the mathematical analysis and its results. This is one work. Second one is a kind of jammer selection. You can understand here. It's a very complex system, and this was the work published in IEEE transactions on your mobile computing. IEEE transactions on mobile computing. This paper was published. Uh, Here, the system is the sensing information is falsified. Primary user emulation attack. It's an industry application of industrial IoT. You can think of there are two factories, factory 1 and factory B. I mean factory A and factory B. They are having the same types of business. Primary users, all there are devices, smart devices. They are collecting data, and this data needs to communicate. Now the respective, I mean the enemy factory or the factory likes to disrupt their communication. So one way this like to disrupt the communication by means of eavesdropping, and it can also make use of this information like that. So this is the eavesdropper. So factory B is having an eavesdropper. It is getting use of that one. And there is a primary user who like to disrupt this communication. So a primary user emulation, that means a kind of attacker who likes to falsify the spectrum information. So it will go for a spectrum information, spectrum sensing. That spectral sensing is falsified this primary user emulation. As if a falsified user, they behave like a primary user. It is not primary user. So primary actually is not communication mode, but a pirated form or a falsifier like primary user. It generates a signal, and that signal misleads the sensing information. So in sensing there is a security threat, and in the data transmission there is a sensing security threat by means of eavesdropping. And this is the scheme, and which is jammer selection. Which jammer to be used for eavesdropping protection? Typical application in the CRIOT. So the work suggests a kind of approach: primary user emulation attack in cooperative spectral sensing, nonlinear energy harvesting, eavesdropping during secondary data transmission, and countermeasuring of the jamming selection. So this paper was published in IEEE transactions on mobile computing in 2023, published. So finally, I conclude this one, first part of my talk, that why is here in IoT? The bandwidth allocation to IoT, if you can go for the lease, is very costly. Bandwidth leasing is very costly. If we can use the cellular communications like Bluetooth, cost Zigbee, limited coverage. IEEE 802.22 WRAN ACRN standard suitable for short to long range communication. Now, as I already said at the beginning, the nodes should have a mobility. So IoT nodes should have a mobility issues. By some means, if you can assign one channel, that channel may not be available when a IoT nodes move from one zone to another zone. So it needs a seamless connection. User do not bother about the data, huge amount of data collect, and then they like to dump it to the cloud. But how this dump will be done if there is no channels and all this? So difficult to support single continuous communication like that. So it's the needs of spectrum information. Now limitation in COIB is what? I already say that secondary will sense the data, spectrum information, but this is not always reliable. So even though it is an opportunistic communication, spectral sensing is there, spectral prediction is there, but both primary and secondary has a mutually interference. Means primary communication acts as an interference to the secondary receiver. Secondary communication comes in the form of interference to the primary receiver. So limitation in here, mutually interfering to both an SU node one, demands cognitive backscatter communication in the form of symbiotic radio. So we'll be talking about how the passive IoT communication, cognitive backscattered communication is symbiotic radio, and I will be talking that passive reflector in the form of relay, that IRS meets that condition and IoT communication. So first part of talk is concluded. I'll come to the second part in the next. So thank you. If you have any question, please. I don't know whether I bore you all because it was a continuous one-way communication. I don't know whether uh, it at all reach you or not. Anyway, the end of my first part of talk. Thank you so much for listening. If you have any question, please feel free to ask me. Any communication, any question, any uh, comment, or any suggestion, anything. Hello, hello. I don't know whether organizer is there or not.
Yes, sir.
Okay, so please, uh, I end my first. I think this talk was 10:30 to 12. No, hello.
Sir, should we conclude?
Yes, it is concluded. First part is okay. I think the time was 10:30 to 12. I think no.
Yes, sir.
Okay, so I come just conclude my first part of the talk. I think the
Okay.
second part is from 3 to 4:30.
Yes, sir. Yes, sir.
Okay, so is there any questions or any comments or any queries from anybody?
Do we have any question from the participants? If you
Please,
have any query, please unmute yourself and place your query. Sir is
or
there
you can
to
or you
take
can
the
write
question.
in the chat box, or you can write in the chat box. I
Yes.
hope.
You can also use the chat box. We are ready to take the questions. So if you have any query, any doubt regarding sir session, you can put your questions and sir is there to clear the
I think
doubts.
I don't know whether they are in this talk mostly going through the results or maybe like that. Everybody, I think that's true. So this online mode of communication or FDP program, I was also in a confusion that how it would be, particularly for today. And maybe my talk was also in boring because in one sense I communicate without thinking that
Yes, sir.
if it is boring also you can say so that
No, 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 sir. It
I can
wasn't
make
boring.
myself control for the second part.
It wasn't boring, sir. It was really very, very informative.
So should we conclude this part?
Yes, sir. Yes, sir. So
Okay,
I
so
guess the
then please.
participant doesn't have any question. And if you have also, we are all again having a session with sir today at 4:30.
Please.
So
Thank
meanwhile, if you have any question, you can place your query during that time also.
you. Okay,
And
okay,
for now, we will be concluding the session. Hoping to meet you again for the next session today. And the link will be provided in the group accordingly. So, till then, we will take a leave. And after the conclusion of today's session, we will be sharing the feedback form like yesterday. And also for all the participants, please make sure that you attend all the sessions for getting the certificates after the successful completion of the FDP. And sir, it was an honor to have you here for the first session, and we
okay,
look forward to have you for the second session as well today.
okay.
Thank you
So
so much,
I
sir.
will join. I will join at 3. I hope.
Sure. Yes, sir.
Okay, okay. Thank you so much. Thank you so
Thank
much.
you, sir.
Thank you all for bearing me and listening me. Thank you so much. Bye.